A single grain of sugar holds trillions of molecules. But how do chemists count something that small? Clearly, we can't use fingers or tally marks, but we can use a powerful idea, the mole. Think of it like a counting unit. Just like a dozen means 12, a mole means something much bigger. It's how chemists count particles, atoms, molecules, or ions in quantities that are too tiny to see but big enough to measure in the lab. In this lesson, we'll explore the mole concept and the idea of molar mass, your key to counting the invisible. A mole is a counting unit, just like a dozen equals 12 items. A score equals 20 items. A mole equals 6.022 times 10 raised to the power 23 items. This number is called Avogadro's constant, N. So, 1 mole of any substance contains 6.022 times 10 raised to the power 23 particles, whether atoms, molecules, ions, or electrons. The value of Avogadro's number comes from the fact that 12 grams of carbon-12 contain exactly 6.022 times 10 raised to the power 23 atoms. This allows chemists to connect the microscopic atomic scale with macroscopic lab measurements. 1 mole of a substance means 1 mole of hydrogen gas equals 6.022 times 10 raised to the power 23 molecules. 1 mole of sodium equals 6.022 times 10 raised to the power 23 atoms. 1 mole of NaCl equals 6.022 times 10 raised to the power 23 formula units. No matter what the substance is, the mole refers to quantity, not size or mass. The molar mass is the mass of 1 mole of a substance in grams. It is numerically equal to the molecular or formula mass in atomic mass units U. Examples: H2O molecular mass is 18.02 atomic mass units. Molar mass is 18.02 grams per mole. In CO2, molecular mass is 44 atomic mass units. Molar mass is 44 grams per mole. In NaCl, formula mass is 58.5 atomic mass units. This makes it easy to convert grams to moles in calculations. Here's a visual every chemistry learner should lock into memory: the mole triangle. Moles equals given mass divided by molar mass equals number of particles divided by 6.022 into 10 to the power 23. This triangle connects 3 critical ideas: mass, moles. Moles, particles. Mass, particles. Need to know how many particles are in a certain mass? Or how much substance you need for a reaction? Just start at one corner of the triangle and solve your way across. The mole triangle turns confusing conversions into clear, simple steps. Let's try a real example using the mole triangle. The question is, how many molecules are present in 36 grams of water? Step 1. Find the molar mass of water. H2O, hydrogen has an atomic mass of 1. Since there are 2 hydrogen atoms, 1 multiplied by 2 equals 2. Oxygen has an atomic mass of 16. Total molar mass of H2O is 2 plus 16, which equals 18 grams per mole. Step 2. Calculate the number of moles. 36 grams divided by 18 grams per mole equals 2 moles. Step 3. Convert moles to number of molecules. Multiply the number of moles by Avogadro's number to multiply by 6.022 times 10 to the power 23 equals 1.204 times 10 to the power 24 molecules. Here's another example to bring the mole concept to life. The question is, how many atoms are present in 1 mole of sulfur molecules, written as S8? Step 1. 1 mole of S8 contains 6.022 times 10 to the power 23 molecules. Step 2. Each molecule of S8 contains 8 sulfur atoms. Step 3. Multiply the number of molecules by the number of atoms per molecule 8 multiplied by 6.022 times 10 to the power 23 equals 4.818 times 10 to the power 24 atoms. That's nearly 5 septillion atoms, all packed into a single yellow chunk of sulfur. The mole concept is the beating heart of chemistry. It connects the invisible world of atoms to real-life measurements. It allows us to balance chemical equations with precision, quantify reactants and products in any reaction, bridge atomic theory with practical lab work, master stoichiometry and prepare solutions accurately. Without the mole, we'd still be stuck trying to count atoms one by one. It's the universal translator between theory and reality in chemistry. Let's quickly recap what we've learned. A mole represents 6.022 times 10 raised to the power 23 particles, atoms, molecules, or ions. Molar mass is the mass in grams of 1 mole, equal to the molecular or formular mass in unified atomic mass units, U. The mole is the foundation of all quantitative analysis in chemistry and essential for balancing reactions, measuring substances, and understanding chemical quantities.